And the fourth presentation today is from Chevron Corporation.
Good afternoon. My name is Bob Creek, and I'll be leading the Chevron team in this presentation about our world-class optimization tools and processes. We are proud to be a finalist in the Inforum's Franz Edelman Award competition because it gives us an opportunity to talk about how we've been able to apply operations research to create significant value for our company through modeling and analytics capability. Our presentation today will discuss the importance of the energy products we make, provide an overview of Chevron's downstream business, and highlight the complexity of the decisions we make to deliver products at the lowest cost to consumers. We'll then discuss the approach we've taken to capturing opportunities that, we believe, provide a competitive advantage through the way we've deployed operations research. First, we will focus on our particular segment of the energy business, the downstream, where we convert crude oil into useful products. The downstream is both big and complex.
Energy is how I get to work each day.
Energy is heat in the winter.
And comfort in the summer. It's what makes my cup of coffee.
Light on the ball field.
It's what fuels industry.
Energy is what helps my country grow.
Energy is essential.
It's a better quality of life.
25 years from now, the demand for energy will be 40% higher. And Chevron is developing tomorrow's energy today.
It's a fact. The world is demanding more energy to power its economies, fuel its industries, and improve the living standards of its people. All forms of energy will be needed to meet this growing demand. And it needs to be cost-effective, environmentally safe, and reliably produced. Today, the global energy market requires the delivery of the right product to the right market at the right time. Chevron's innovative planning systems manage the complex integration of crude oil supplies and refinery utilization, ensuring that a steady supply of fuels and petroleum products are available around the world. At Chevron, we're helping to deliver the world's energy needs today.
Next, let me introduce Mike Wirth, whom you will hear from in this next video. Mike is the Executive Vice President in charge of all the downstream and chemicals business, reports directly to Chevron's Chief Executive Officer and Chairman of the Board, and is one of the top 3 leaders in our company.
We have operations around the world, from raw materials, crude oils, and inputs, into our refineries, to manufacturing of finished products, and fuels, lubricants, and then distribution of those to the marketplace. It's a large, complex business. We sell products on 6 continents, and every crude oil in the world is different. Every refinery in the world is different, and they sell into different markets. So the value of a crude oil to each refinery changes based on the markets that it sells into, the makeup of the oil, and the capabilities of the refinery. So we need very sophisticated operations research tools to understand the decision-making alternatives at every step along that change. Petro is a world-class operations research tool that allows us to make the best economic decisions in markets that are very dynamic on the feedstock side, against assets that have very different capabilities, and into finished product markets to get the best economic outcome across that entire chain. We use the tool every day in short, medium, and longer term time applications, and it allows us to compete, hold our costs down, and ultimately produce our products at the lowest cost possible, which is important for a world that depends on affordable energy.
Next, let me introduce Mark Davis, who leads the team that optimizes our facilities on the West Coast of the United States, to talk about opportunities.
As you have just seen and heard, Chevron's downstream business is large and complex. The supply chain, from crude to customer, presents us with opportunities for optimization. We are constantly trying to find better answers to business questions like which crude oil to buy and how to deliver it to our refineries, how to operate our refineries to convert crude oil into usable fuels, how, when, and where to deliver our products to customers, how much of each product should we make based on market prices and consumer demand. In order to optimize the crude to customer supply chain, our operations research tool must include the entire breadth of our supply chain. Our tool, Petro, includes all crude types and qualities, simulates refinery processing and routing capabilities, and understands market prices and demands. Let's start at the beginning of the crude to customer supply chain. Most of the feed to our refining facilities is crude oil that is produced in fields all over the world. Crude oil is produced worldwide at a rate of roughly 80 million barrels per day to satisfy the world's demand. One fundamental difference between crude oil and products is that crude oil contains a wide array of hydrocarbon molecules, which boil from room temperature to well over 1,000 degrees Fahrenheit, whereas products boil over a much narrower range. The amount of material within each product boiling range and the amount of sulfur and hydrogen the oil contains varies considerably from field to field. Another difference between crude oil and products is that crude oil contains appreciable amounts of sulfur, while most product specifications require very low sulfur levels. These are just a few of the many factors which influence the ease of refining a crude oil into products. This chart illustrates the variability that exists in crude oil yields. In addition to yield, crude oil is also characterized by hundreds of distillation and quality parameters, like sulfur and hydrogen, to determine its suitability for refining. The price of each crude oil is very much a function of its quality. Crude oils that have more material in the gasoline, jet, and diesel boiling ranges and lower sulfur command a higher premium in the market. Difficult to process crudes are discounted in the market. Quality-based price adjustments change constantly with market prices and availability of competing crudes. The cost of transporting crude oil from its source to the processing refinery is also a consideration in the price of crude oil. Refineries convert crude oil into products which fuel the world. A large portion of these products are transportation fuels, including gasoline for automobiles, jet fuel for airplanes, and diesel fuel for trucks and railroads. Refineries can also produce products like lubricating oils, chemicals, and lower value fuel oil. Refineries are made up of process units, each of which serves a purpose in converting crude oil into sellable products. A typical refinery is composed of the following process units. Distillation units separate crude oil into product-specific boiling ranges. Cracking units convert the heavier parts of crude oil into products. Treating units remove impurities like sulfur and increase the hydrogen content of fuels to reduce air pollution. Gasoline production utilizes special processes to meet the octane specifications you see at the pump. Products from individual processing units are blended into final sellable products. Most refineries contain these basic process units. However, of the roughly 500 refineries in the world, no two are alike. A refinery's capability is the combination of type, size, number, and flexibility of its process units. Refineries can shift the amounts of products they make by altering the operating conditions, temperatures and pressures, of process units, and by altering stream routings. For example, a refinery can make more diesel fuel at the expense of making jet fuel. But jet and diesel prices alone are not enough to drive the shift. The refinery's costs associated with making and distributing each product must also be considered. Because diesel product specifications require a low sulfur content, diesel must be treated to remove sulfur, whereas jet fuel does not require this additional processing step. the additional costs of treating must be weighed against the price difference in order to understand which product is more valuable. Comparing our refineries' cost to produce relative to market prices for products is the ongoing product optimization opportunity. Crude optionality, refinery capability, and market price volatility create an ongoing optimization opportunity in the crude to customer supply chain. Finding the best fit is how we increase efficiency in delivering products to consumers. This optimization is done at each of our refining locations on multiple time horizons using our standard operations research tool, Petro. Because of the size of our downstream business, just a 1 cent per barrel improvement in this optimization yields Chevron millions of dollars a year in reduced costs. The following example illustrates the options which analysts using Petro might consider in addressing a typical business challenge. The challenge involves balancing sulfur between the sulfur content of the gasoline blend streams produced in the refinery and the requirement to stay below product gasoline sulfur limits. This is an ongoing real challenge as the industry works to reduce sulfur in products to meet increasingly stringent air quality standards. There are many potential solutions to the sulfur balancing challenge. Commercial solutions might involve buying different crude oils or selling different grades of gasoline that allow higher sulfur content. Refinery operating solutions might involve increasing the sulfur removal of a treating unit or rerouting of high sulfur streams. To create additional sulfur balancing flexibility in the longer term, the refinery might consider investing in another treating unit. Petro models are configured so that all of these options can be readily evaluated. Ted Kutz, Senior Consulting Engineer, will now discuss approach and methods. Ted is Chevron's most senior Petro practitioner.
When we were considering what optimization method would work best for addressing the opportunities presented here, we kept the following criteria in mind. Whatever approach we selected needed to solve fast and converge. It also needed to optimize over the entire refinery while achieving a reasonably detailed and accurate representation of the refinery processes and stream flow. Because the capabilities of the refinery shift over time, we also needed an approach which would allow quick and easy updates to the model. Of the three methods shown here, linear programming with distributive recursion, and other nonlinear techniques such as sequential linear programming, linear programming with distributive recursion emerged as the clear winner when applied to our specific application, both for Chevron and for the rest of the refining industry. The example presented here demonstrates the advantage of recursive LP over conventional LP. Consider two feed streams, the red feed and the yellow feed. We can buy 50 units of each feed, and each costs $68. The two feeds can be fed to two destinations, a cracking unit and a product blend. Based on their cracking unit yields, the value of the red feed to that destination is $80, while the value of the yellow feed to this unit is only $70. When fed to the product blend, the value of the red feed is $74, while the value of the yellow feed to the blend is $72. With a typical LP model as proposed in our industry for this application, the optimal solution routes all of the red feed to the cracking unit and all of the yellow feed to the product blend. The value of the two feeds, $80 and $72 respectively, are based on their destination. The objective function in this simplified example is calculated by multiplying the amount of each feed by the difference between its value and cost. The result is $800. Conventional LP works fine for modeling this problem so long as the red and yellow feeds are segregated. However, in refineries, feeds are typically not segregated, but they are pooled, either because of tank or pipeline limitations or because they are processed simultaneously in the primary distillation units. When the red and yellow feeds are pooled, they create the orange blend, which has a value of $75 in the cracking unit and $73 in the product blend. When pooling is brought into the picture, the optimal solution is to feed the entire 50-50 blend to the cracking unit. Introducing the pooling constraint reduces the value of the objective function from $800 in the LP case to $700. Distributive recursion correctly models this optimization and the pooling of the stream's qualities. Moreover, even though the streams have been pooled, the distributive recursion model captures the fact that the value of the red stream is $80 and the value of the yellow stream is $70 as a cracking unit feedstock. This is achieved by keeping track of each stream's qualities that influence its value in the cracking unit as the solution proceeds from step to step. This direct connection between feed qualities through the process units to final products is what allows refinery feeds, including crude oils, to be properly valued based on their qualities. How do we calculate the value of the red and yellow streams? In a distributive recursion LP model, the value of each stream is determined by its qualities via the following equation. Value is equal to A plus BX plus CY plus DZ, and so on, where X, Y, and Z are the stream's qualities, for example, sulfur content, density, and octane. A, B, C, and D are established by the value of each quality, which in turn is determined by the destination of the stream and the downstream constraints. A, B, C, and D are not constants, but they change for every case. This approach is the same for any number of stream qualities. 2/3 of the 10,000 equations in a typical model carry stream information. So far, we have focused on the mathematics underlying Petro. While selecting the right mathematical method is vital to the success of building a refinery optimization model, many other technical and organizational elements need to be in place in order to turn opportunities into value. Some of these include modeling, reporting, data quality, and system improvements. Methods for modeling the refinery to get the most out of the mathematics needed to be learned and applied. Complex refineries like the ones we model at Chevron have a lot of flexibility to change their product mix. They also have a lot of constraints which influence the economics of changing this mix. In the cracking unit shown here, the yellow dots represent areas in the process where we can optimize. These include the feed rate to the unit, the catalyst rate and type, the temperature of the reactor, and the way we separate each of the products in the distillation column. Most of the areas for optimization are also potential constraints. These are represented by the red dots. Our models take all of these into account for each unit in the refinery. Our models are large, single-period, single-refinery models used for crude oil selection or capital studies typically contain 5,000 to 10,000 equations. The number of equations doubles when we model 2 refineries for the purpose of regional optimization. Multi-period models, which are used for near-term product balances and to plan around shutdowns, can contain as many as 100,000 equations. Despite these model sizes, solve times are very fast. The 25 to 30 planning analysts who work with Petro cases each day have a lot of information to sort through. To help them with this difficult task, we have continually improved the reports. Reports have 2 main purposes for analysts: understanding how the case is set up, the input, and understanding what message the case is delivering, the output. Many of the reports are designed to allow analysts to compare and understand the differences between cases. Multi-time period models require a whole new class of reports to foster understanding of what is happening from period to period in a given case, as well as the rolled up result of all of the periods. Petro also has reports to help modelers understand the impact of the changes they make. Modelers use comparison reports to communicate to analysts what they can expect to see when they start using a new model. To give you a view of Petro's reporting and other capabilities from the vantage point of an outsider, I'd like to introduce Joe Corvers. Joe is a consultant and partner with Stansel. He and his colleagues build and support the Petro models we license to other companies.
What caught my eye in Petro was the reporting capabilities, the user interfaces, and the case sharing, which really promoted collaboration. I have clients that have been using Petro for about 10 years, and I'm still building new models for new clients today. For a 500,000 barrel a day refinery or enterprise, Petro should be able to bring $300 to $400 million per year net revenue improvement. My clients benefit from using Petro because they're able to really analyze their problems at a much deeper level and more thoroughly and more expeditiously. Petro's reporting capabilities are outstanding. It also has very useful user interfaces and a very strong case sharing and case management functionality. The filtering function allows the user to expand or collapse the report to hone in on the economic drivers and the useful information that they're targeting. It really increases their productivity in getting to the answer. Petro has a very stable recursion algorithm. Stable recursion algorithm benefits the users in that you get a good solution every time. Other tools don't have a stable algorithm. Petro is unique in that it freezes the matrix for the users. This allows the process to be faster, and it also creates model integrity over time because now everybody is using the same model. It answers that age-old question of who has the official model. Petro has been investing in their product so that it continues to grow with improving technology and computer capabilities. Bottom line is Petro leads to clarity, confidence, and collaboration, which generates smarter executable decisions.
Petro is built on data, and the quality of that data is a key determinant of Petro's accuracy and value. There are a number of sources of data for Petro. Some of these go into the underlying model. Others are specific to a particular case and time period. For many of these, we have made significant improvements over the years. In recent years, our crude oil analysis team has instituted a grading system which automatically triggers an update once data falls below a certain score on a standard test. When the data on any crude oil is changed, Petro analysts are notified through a special report. Refinery engineers have made great strides in organizing the performance data on the distillation, treating, and cracking units. In addition, breakthroughs in distillation measurement techniques have allowed us to validate refinery performance more closely. Our refinery process experts continue to advance their processing unit models, particularly in the critical area of catalyst use, where we incorporate the nonlinear catalyst life correlations into Petro. Because the market data, prices, and demands change frequently, we have initiated methods to automatically load this data into Petro. This frees up analyst time for higher value work. Now I'd like to reintroduce Mike Worth, our Executive Vice President, who will discuss the management support for the development of Petro and the importance that Petro plays in linking the data we discussed here to the business.
We support continuous improvement of Petro through the ongoing expectations that we set, high expectations that as technology improves, capability of information systems improve, as our technical understanding of our business continues to evolve, that all of these things are brought into Petro in a series of upgrades and enhancements so we can take the foundation that has been built over decades and continue on a regular basis to keep it at the leading edge of tools like this in operations research. We use it constantly. We expect it to be at the world-class level where it is. We provide the resources and support to ensure that it continues to stay sharp.
I'd now like to reintroduce Mark Davis, who will discuss the people and process portion of this presentation.
Applied operations research is more than just a model or tool. It requires the support of people and processes to make it effective and create value. We will now talk about how we support Petro. Modelers validate the Petro tool through continuous tuning and periodic updates. Tuning can be implemented by modelers or analysts and can be done on the run with our model construction. Model updates to an existing refinery model are done once or twice a year and are typically triggered by larger structural changes, like adding a new stream or process unit. Modelers are skilled at developing models which accurately represent the range of capability of refinery operations and solve quickly. We also support only one Petro model to serve multiple business needs. At any given time, there are multiple analysts running Petro. A typical analyst is a mid-career professional who has a chemical engineering degree and knows refining. This background is very important for both interpreting Petro results and for helping to implement solutions. Being an analyst and running the Petro tool is a valued experience for many Chevron management positions. You will now hear from Mike Worth on how Petro contributes to developing future leaders, and Stephanie Ravita, a former planner and current leader.
Petro has a key role in developing leaders. We bring in smart technical people. We hire a lot of engineers who come in that may not really understand how we make money. Petro integrates the operational capabilities of our assets with the commercial realities of the marketplace. So our technical people, as they use this tool, they learn the economics of feedstock selection, of manufacturing, and of product distribution. So we're a company run primarily by engineers. Our ultimate managers and leaders of the future need to understand the commercial realities of our business as well as they understand the technical dimensions of our business. And Petro is essential in developing that full set of skills for our future leaders.
Using Petro has shaped who I am. So I started work in the Pascagoula refinery 20 years ago. And after a few years in an engineering role, I moved to the planning organization where I spent the next 10 years either using, supervising, or managing those who use Petro. So not only have I developed the skill set to use a very complex model, but the training we go through, the way we shape the capability of our analysts makes you look at business decisions differently. Petro drives product trading decisions by generating outputs that the analysts then discuss with the traders and look for potential market opportunities to capture the preferred alternatives according to the Petro model. Petro is a major part of our decision-making process at Chevron. It's the foundation of many of our multi-million-dollar decisions that we're making in Chevron. We're finding opportunity to use Petro in all types of decision analysis for us. So I fully expect and I hope to see Petro used more in our downstream business. I can't imagine a world that we're not using Petro or using it even more in the future.
One reason we have a large number of analysts working with Petro is because of the breadth of the optimization. We have analysts focus on different parts of the crude to customer supply chain to extract maximum value. Analysts that sit in the refineries are focused on ensuring that refinery capability is reflected correctly in the model and that optimization solutions are executed. Analysts focused on crude supply sit with crude traders to quickly capture opportunities in the crude markets. Similarly, analysts focused on product supply sit with product traders to find opportunities in product markets. Regional analysts focus on opportunities to integrate our individual refineries toward a larger regional optimum. To ensure that all of these analysts are aligned and seeing the bigger optimum, there is a need to share and collaborate on cases. Cases created with Petro are easily shared between users, creating effective work processes. This also allows for mentoring and training by our more experienced planners on case setup and interpretation. Over its 30-year history, Petro has become a central tool in our downstream business, whereby a number of other tools link to Petro either through shared models or shared data. How can we be sure the plans we develop in Petro are executed? Linkages to models which are involved in execution is one way we do this. We are able to export our Petro process unit models to our refinery scheduling tool through a matrix squaring method in Excel. Scheduling tools are used for daily planning of unit feed rates and tank inventories. Our blending tool support team works closely with our Petro modelers to ensure that both blending and planning models are aligned with common data. Petro modelers work closely with our process control and optimization teams to communicate how to control our process units on a continuous basis at the optimal conditions. distribution supply chain management tools, as well as decision analysis tools, use Petro refinery stock balances as inputs. There is a strong linkage between Petro and our capital projects through our decision analysis tools. Uncertainties exist in future product demands, crude and product prices, feedstock availability, and refining capability. These uncertainties necessitate the development of multiple cases within Petro. These cases are passed to the decision analysis model in the form of refinery stock balances. Sensitivity analysis is then done in the decision analysis model to guide our roughly $3 billion per year in downstream capital spending. Petro analysis has also identified lower cost or no cost alternatives to meet changing environmental and product specification regulations. Petro generates sizable value to the downstream business through improved capital spending. Now we are going to hear from Mike Coyle, who is our decision executive on many of our large capital projects, about how Petro contributes to his development and to his capital decisions.
I used Petro back in the mid-'80s in our Salt Lake refinery. Using Petro early in my career really gave me a good view of how a refinery was put together, and it really educated me, and I was able to use that throughout my career of different jobs, operating jobs, all the way up through refinery manager. We would use Petro to look at projects to increase refinery profitability by increasing yield or meeting some new environmental regulation. We can't predict the future, so we try and look at cases that look at possibilities in the future. And the teams will use Petro and other decision analysis tools to help them make a proper recommendation. The Petro tool is a competitive advantage for Chevron. It allows us to produce product more efficiently than our competition. The operations research tools we use are crucial to Chevron's financial success.
These are now all of the elements that link business questions to real value capture. Continuous improvement means working on all of these links and focusing on the weakest link. Effective application of operations research is more than just the tool alone. It requires the support of people and processes to be successful. Now here's Bob Creek again to quantify the benefits Petro brings to our downstream business.
Before we get into the details, there's one aspect of our long-range planning using Petro that we haven't introduced, namely the use of Petro as we work with government regulatory agencies. Here's Bob Anderson to tell you more.
In my role as Senior Fuels Policy Advisor, I work closely with the government agencies to understand the objectives that they are trying to meet in improving air quality. And when they come up with an idea for a new fuel regulation, we help to work with them to define the best ways to achieve those environmental targets. Quite often, the regulations will involve us having to make a change in the products that we're producing and selling to our customers. So our knowledge of refining, both from the technology and the economic side, allows us to identify the best options and help communicate those to the government agencies so that they can consider those when they're making their decisions. Petro has helped Chevron respond to changes in fuel regulations by giving us a very accurate and effective tool to study different options that might be proposed for our businesses. So by using Petro to plan for an upcoming fuel regulation, we will be able to reduce and minimize the cost of producing that fuel for our refineries and be able to reliably supply the fuel to our customers in the most economical manner possible.
This is a summary of the impact that Petro enables in Chevron's downstream business. The total comes to $1 billion per year, a significant portion of our downstream earnings. About $600 million a year comes from optimization of the crude to customer supply chain through crude selection, product optimization, and refinery unit optimization. Another $400 million a year comes from better stewardship of our capital by avoiding projects we don't need and improving the projects we do. In addition to the hard dollars, there are other significant benefits. You've heard about how Petro has shaped the careers of our current leaders and continues to shape our future leaders. You've heard about the complexity of our business and the number of people engaged through the supply chain, Petro enables communicating the right goals and results with confidence and aligns all organizations in the supply chain. Petro gives us a superior way to translate the mountain of data we have available to us into information that guides our business. Finally, you heard about the impact Petro enables for our licensees, $300 to $400 million per year. Adjusting for the size and complexity of the refineries that Joe supports compared to Chevron's refineries, this estimate is very consistent with the $1 billion that Chevron realizes annually. We've used Petro to enable our business optimization for the past 30 years, but the annual value that we see has increased over that period and is greater now than it has ever been, with every expectation to continue to grow. Overall, Petro has enabled capturing $10 billion over the last 30 years. Here again is Mike Worth, Executive Vice President, Downstream and Chemical.
Chevron Operations Research Tool, Petro, brings and enables $1 billion of value to our company every year, and some over $10 billion over the last 30 years in informed operational decision-making as well as smarter capital decision-making. So the insights from this tool are essential to our business. We've supported the ongoing development and improvement of this tool over decades, really to allow us to continue to provide affordable energy into the markets and customers we serve so they can be highly competitive and highly successful. Thank you for including Petro for consideration for the prestigious